Hello, and that wobbled like fuck. I know what you're thinking. Where do babies come from, and why is the sky blue? Now, don't know the answer to them, but what I do know what you might be thinking is, where the fuck's the robot that we'll be making? And the long and short of it is, it's sort of on hold for now. Essentially, because we're wanting to make it circular. If you don't know what I'm talking about, there's a couple of videos from a while ago. Should be making an axle for it and stuff, and the concept design, a few of the engines we got for it. But essentially we wanted to make a spherical robot, battle robot thing. But getting the parts made spherical and all that is super expensive, and we're trying to do it on the cheap. So until we can work out a way around that, we're sort of putting it on hold. However, I still want to make a robot, and I'm still going to. Design has just changed a bit. So this one's going to be a bit more traditional. It's essentially like a mini tank. If you picture a sort of square thing, heavily armoured, big wheels, maybe not that fast, but you know, enough to move it torquey, more than anything, and a fuck off drum spinner on the front of it to mangle things. I wanted to do a few other things. I wanted to originally do a bar spinner. For anyone who doesn't know what that is, it's something that sits like that on the end of the robot and spins and hits things. And it spins very fast and hits things. The downside to that is, if you can imagine that this is the enemy robot, and you come in and the bar spinner comes in and you catch it just on the edge. And your robot's about here. Essentially what you've done is you've just turned yourself into a massive lever, and yes, you'll move him that way, but the force equal and opposite reaction, you're going to go that way, and there's very little you can do to counter that. That's just the way that it works. You hit them with a lot of force. Now, the closer you are to hitting them, so the farther down the actual blade that they are, the less this force is exerted on you, because it's a lever. So the closer you are to the fulcrum, the less energy is passed on to you. Same applies for him though. So that was a downside to that, and that is the biggest downside to bar spinners, is that they are as destructive to themselves as they are to the other robots around them. A drum spinner, however, is a bit better. So a drum spinner is, well, we'll use this. So it'll essentially sit at the front of the robot like that and spin like so. And there will be stuff on this to catch the enemy robots as it spins. Now the good thing with that is, if your robot's coming in like so, so the enemy robot comes in and you catch it, your force is going to flip them backwards or push them backwards. But the force that's going into you is actually pushing you down. So if you are moving to engage one and you're wanting to maybe push them about a bit, but they've got more torque and more traction than you, if you hit them with this, you're lifting them up a bit. Even if they're too heavy to fling about, you're still lifting them a bit. So you're removing their grip, while the force that's lifted them up is also pushing you down, giving you more grip, which means that you, albeit temporarily, might be able to get that edge and actually push them about a bit. So that's kind of the thinking there. And if we make it small, heavily armoured, make it survivable is the big thing, because you get a lot of robots that are really powerful, really destructive, but they fall apart in seconds. So we want this to be relatively small comparative to other battle robots out there. So it's quite compact, but make up the weight in armour and beefy motors. Speaking of beefy motors, I'm keeping this on the cheap. Here is what I am currently going to use for the drum. This is a motor taken out of an electric lawnmower. Now it runs usually on 230 volt AC, which is what our mains voltage is here. I have tested it. It will run on DC fine. It's not invertible, so it will only spin one way, regardless of which way around you put the polarity. That's an AC motor, is somewhat expected. This plastic crap here, I've kept it on for now because I'm thinking if you picture that that's the drum, I might have it mounted somewhat like that. So I might keep this plastic just because it'll be a handy place. There's a slot in there for a bearing, and I still have that bearing. So it'll make it easier for me. I don't have to then make something that this can fit into. I can just use this. So I haven't destroyed this just yet, but I might. One thing that I will take out after I'm finished building and testing, so before I actually put this into any fights, apart from test fights maybe, there is a thermal sensor in here to cut it off should it overheat. In testing, I would want to know if this starts overheating, but in an actual fight, if there is any sort of flame weaponry or heat in the actual battle arena and it triggers this, our weapon's dead. So that will be getting taken out of this anyway. I will be putting a couple of sensors in to monitor temperature and the likes, just to make sure that it's not dangerous, especially if I use a lithium ion battery and stuff in there, or lithium polymer. I mean, they go on fire for no reason, so I'd want to monitor that so that you have to keep yourself safe during these things. As I said, this runs on 230 volt AC. Now I am going to be running the robot of 12 to 24 volts DC. Not quite sure which one yet, I'll see. And 12 volts, anyway, I've tested this, does not make this budge. So what I've had to do is use one of these. I might use a different one actually in the robot because this is quite bulky, but we'll see. I might have more room than what I think. This is a boost converter. So what this does is this will take in 12 volts and well, it'll actually take up to 24 volts, but it'll take in 12 volts, so I've been testing it so far. And then you have two potentiometers here, which allow you to adjust. Now here's the kicker. Whenever I got this, I was told it will not, you can't alter the current. But there's two potentiometers here, and one of them alters the current, and one of them alters the voltage. So I don't know whether the person who was selling this... Okay, so my video decided to shit itself there. So I'm not quite sure where it cut out, but I believe I was talking about this, and the variable current. Like I say, I was told that this couldn't, this wouldn't be able to do variable current. We've got two potentiometers here, and one of them is labelled current. Oh, I don't know if you can see that or not, but it does seem a bit flaky, for want of a better word. I don't think it does it quite well, which is maybe what the person was talking about. Now, like I said, this can run on either 12 or 24 volts. I believe. I might let the smoke out of it if I put 24 volts through it, but we'll find that out in a later video. Pretty sure it can. At the minute I've got this set up more or less at its max. It does say in theory it should go higher, but it doesn't. I can put 12 volts in here and I get 80 volts out of here DC, and 80 volts is enough to make this go like the clappers. I'm going to put in a wee video here now of it going. And there you go. So that was it, running a dummy drum spinner, just a bit of wood and a couple of bearings. But I wanted to see whether it would actually take it with a bit of weight on it. So that is what I will be running that from. I also have these. We're going to use these on the sphere, but obviously since it's postponed, I was thinking of using these as drive motors now. The problem being they go very, very fast on 12 volts, but they have very little torque. So I made a wee rig, for want of a better word, where I put two of these on either side and attached them to wheels, and I sat on it and gave it power. It didn't go too well, It didn't like it. There just wasn't enough torque to move me and the battery and the wood and everything else. And I mean, I'm not that heavy. I'm only about 9 stone ish, so not a lot of torque. What I could do is get some gears and do a bit of gear reduction to help that, but I was thinking about it, and it would be very, very fiddly, and I think the better option is to get a pre-built unit, which is what I'm doing. And I have a couple coming from China, I believe, or somewhere thereabouts, which is a pre-assembled motor and gear housing, which should give enough torque to move the robot. I'm going to use the same rig once they arrive, and I'll actually video me adjusting that, and put wheels on it and see if it will then move me, if it has enough torque to move my weight. As long as it moves me a bit, I'd be happy. Now I know the robot is probably going to be far heavier than me whenever it's done, but if I have them and they work a bit, any motor that would be sufficient probably isn't going to be massively bigger, unless I go for something absolutely huge, but I don't want to do that. So it should work fine for sizing. So once they're here and I've tested them and they actually work a bit, now they might work fantastically and hopefully it'll work great, but if they don't, even if they work a bit, they'll suffice so that I can actually then start building the frame and planning out where I'm going to put all the electrics, the receivers, where's the weapon going to be mounted, how much space do I need for all that, and all that good stuff. Speaking of electrics, I do not have any ESCs, which are electronic speed controllers, because I don't think I need them. For the likes of a drone, you know, an ESC, being able to control each of those motors very precisely is important. On this, I don't think it's as important. The drive wheels are just going to need to move and get up to speed as quickly as I can within reason. I shouldn't need to worry about the wheels spinning because it's going to be one heavy bugger, so shouldn't be an issue. So just having them on or off should be fine. That might change. I'll obviously iron that out in the testing, but for the meantime I'm doing it without an ESC. And the same for this. Now for a drum spinner, you might know that there is a sort of butter zone of speed, so that it's going fast enough that it's got enough momentum to actually do damage and pass that energy on to the other robot, but not so fast that it then just it's more likelihood that it's going to hit the actual drum plate than the spinner, or it's going to hit the spinner, the actual bits that catch on the spinner, it's going to hit it too early and not get a good contact. So there is a nice sort of Goldilocks zone, for want of a better word, for a drum spinner, but I don't think I'm going to need to do that on the fly. I think that'll be very much something that's set, and then you sort of go with it once you're actually in the fight, and even if your settings are off, you just sort of deal with it and carry on the fight. And I can do that in between fights by adjusting the potentiometers on here and adjusting the output voltage, which will then vary the speed of this motor so that we can try and get an ideal speed. With this, I'm not too sure what the best way to run this will be. I have a couple of ideas. So if you picture that this is the receiver, and there'll be wires coming off it, and there'll be some of those wires will obviously be going to here, and some will be going to a power distribution unit, so that the right power goes to the right component. I'm thinking of having a remote switch that's obviously connected to the receiver for either on the positive or negative on the input, so that I can then remotely trigger this and close this circuit, which will then spin up this. I was thinking about doing it on the output, but then this might be draining power. Well, sorry, it will be draining power in some form while it's just sitting idle. So I think the best bet is to put a switch on the input and just have this controlled as one unit. Yeah, I'm thinking that's the best bet because I just need this to be an on or an off, and then this will get itself up to speed. So I think that's where I'm sitting at the minute with electronics. I have a small receiver unit that is, cannot remember the make offhand, but cheap and cheerful, and it might be replaced in the future if I can't get a receiver that'll work with it. I also have an old drone kicking about that's broken, and I might actually be able to nick the receive components out of it and use them, which would be good because that would keep things cheap and cheerful. So that's it for the update on the robot. I'm going to be doing a couple more videos once stuff actually arrives, and a bit of testing with this, and once I start getting the frame together. So hopefully this will keep going as a more recurring series. If you haven't noticed, I have started doing videos about radios. I'm a bit of a radio buff. I quite enjoy them, so I'm doing some bits and pieces on sort of basics of what is radios and antennas and the likes of that there. So feel free to check them out if you're in any way interested, and see you soon.